All right, let's talk measurement for a moment. Where's this guy's eyeballs? I'm going to turn solo mode off. Let's just reload that. Get rid of the poly paint, come over here to matte cap gray, and adjust my color swatch all the way to white. Okay. So, measurements. How do measurements work inside of ZBrush? Now, the first thing that we really need to be aware of inside of ZBrush is everything is scaled to one ZBrush unit. And we'll hit this concept many times in this course, but we kind of need to talk about it right now, because this one ZBrush unit is why there is no real-world units. It's the cornerstone to why there is no. Now, there's a reason why Pixologic created their own measurement system, so to speak, instead of using real-world centimeters or real-world units, which technically they could have done. But does anybody want to take a guess on why ZBrush would not use real-world units? Just think about it for a second. You know, think about it like you're creating your own program. Why would you not use real-world coordinates? So Steve says faster math for calculating tons of polygons. And Ryan's basically saying the same thing. The primary reason has to do largely with infinity, or largely with large numbers as they approach infinity. So what do you do with the calculations there? If you're in Maya, Maya's job is literally to calculate everything. You know, it has delimiters that keep it from calculating things into you know, infinite space when there's nothing there, but it has to calculate a very broad range of things. The other thing to keep in mind is floating point math. Okay, the older computers back in the day, you know, floating point wasn't a fast system. If you were doing your math in floating point math, then you started to lose time for each processing calculation, because you're calculating a lot more. Floating point basically means something's 1.0000003657, as opposed to just, you know, here we're at 1 or something like that. Floating point lets you get into infinite space. And in the beginning, that didn't work for the computers that ZBrush was operating in. So you had to limit things into a more comprehensive system. Something that would allow limited computers to process data quickly. That was a very significant, important innovation in the software, because everybody who tried it before tried to do it with real-world units, which at that time was not possible. Now may be a different story. Floating point math, there's no difference in performance cost at this point. Absolutely none, because of the way processors are built now. So in short, when you enter into ZBrush, you enter into a very specific contained space. That space may be very large. It may be, for all intents and purposes, it might be infinite, in that it is larger than you can personally calculate. But it is not infinite. It is a contained space. Let's just say that for argument's sake. And inside that is all of these little ZBrush units. And you'll really get a sense of these guys if you come down into, where'd they put it? if you come down to size, so you go to geometry, you go to size, you can see there's a modifier there. That modifier is, 0.1 in this case. And then you go to the very bottom of the tool palette and you see export, and you see modifiers here. And then if we come into preference, let's see if we can remember where they are. Okay, and then import. Utilities, these aren't really relevant even though they look like, yeah, import, export, there we go, export. Okay, so inside here there's a bunch of things that modify how something comes in to ZBrush as well. So if we look at, say, flip Y, flip V, these are actually on by default. So inside this box, not only is it limited, but it's actually got a different way in which the camera is looking. And that's just part, there's no flavor, no specific reason other than that was the flavor that was chosen at code time. And if I remember right, Max was one way, and now it's more like Maya. But I might be wrong there. All of this to tell you that inside ZBrush you are in a benevolent dictatorship, and you are within ZBrush's own definition of space-time, so to speak. And you have to be aware of that both on import, export, and when doing measurements. Any questions about that? Or if you've run into a situation like that, post it up, let us know. So now how do you get real-world measurements into ZBrush? Anybody want to hazard a guess? How do you get real-world measurements into ZBrush? There's actually a real simple way. I'm waiting, seeing if anybody can type it up. Yeah, Kathleen, do them in another app and import them. Charles, import a ruler. Okay, but there's a really important thing that you got to keep in mind, and this is really, and thanks for answering that question, because this is exactly what I wanted to explain. When you import a model, ZBrush adjusts scale so that it'll fit within its world view and in the safest way possible. So if it's a really large image, it'll scale it down quite a bit. If it's a very, very small model, it may very well scale it up so that you can do calculations better. Either ways, it's going to adjust it. So every time you import, you adjust the scale. That means that the scale is always different. Always different. So every single model that you go into, if you go here to geometry and size, these are going to be different. You want to test that out? Let's just come into, let's say, one of the dogs, or let's just load it. So we'll go into tool. Let's bring Zax in. Super average dude. So what has he got? He's got an XY size of 2. His X size is adjusted here. And now if we come back to our guy, different units in there. It's possible. Let's check, see if Zach has exports adjusted. No, everything's fine. So every time you import, it adjusts. So let's say if you import a ruler, then this is adjusted. Let's say this is 0.5, and then you import a face, and this is 0.7 in terms of that X, Y size. How are you going to get those so that they're exactly the same? Of course, you can adjust these X, Y size, but I can guarantee you'll go a little nuts. Steve, I'm hearing mention deformation and unify. But if you use unify, if I remember right, yeah, everything is scaled essentially to one ZBrush unit, and that's not what you want, because now suddenly the ruler and the head become the exact same size. And we can demo that very easily by just going into one of these subtools, like let's say the teeth. You know, the teeth are small in there and the body is big, right? So I don't know what's going to happen because I haven't done this before, but deformation and unify. Ba-boom! Those teeth are scaled so that they fit within one ZBrush unit. And in this case, it's not scaling them vertically, it's scaling them horizontally, which is again one of those odd things. It's a very dynamic adjustment of the scale. Very, very, very dynamic, and that makes it hard to predict. Someone's mentioning transpose units. You come in here and transpose units to get those measurements to be the same. But that's not going to quite do it either. Let's come in and see if we go to geometry, 0.138, geometry, 2.043. So even among these subtools, this changes, 0.116. But if you want this ruler, let's say this is 12 inches, and you want this human head, let's say that's 8 inches tall, to be the exact same measurement inside of ZBrush, the exact same relative size, the only thing you really have to do is just make them subtools of each other. That's it. So if you import the ruler and then you import the head, the next step is that you append the head to the ruler. And at that case, they will assume real-world relationships to each other, and their real-world relationship will then be adjusted as a whole. Does that make sense? So real-world units in ZBrush can be gotten by importing a model with some specific unit. So it'd be like I would import a cube that I know from one vertice to another, and you would measure vertices because ZBrush can lock to vertices. One vertice to another, that equals 1 centimeter in Maya. I would import that in, and then I can append that to any of my models here. And so if we append it to this guy, it might be down here. And we know that's 1 centimeter, and we just count on up. Now, if you don't use a program like Maya or something like that, then it's harder for you to get the real-world units. So then you have to ask yourself, do you need real-world units? If you're an artist creating an organic character, you don't need to know that the eyeball is 24, let's say 24 millimeters. Exactly. You know, you just need to know this is my eyeball and the human head is five eyeballs across. And then you build your measurement out from there. And in this case, you're just like a painter or draftsman, and you're making relative measurements on your model based on some arbitrary choice. As my teacher Oliver Grimley would do, you would start a cast drawing. It could be an entire figure, some kind of heroic pose, the guy is holding on to some kind of javelin, making some macho pose. You would do that entire thing with one measurement unit. The eye. Really, really hard. Nobody finished their drawings that term. But this works for centuries. I mean, this works. This is a relative unit of measurement, and that will work just fine, and that's what ZBrush really focuses on. Relative unit of measurement.